Okay, I was just messing with you guys. It's hard to remember these related rates problems, so don't hold that against me as far as my comments on my last email. But, however, you hopefully after seeing this you'll remember how to do it. I'm just going to get you started. Let me know if you want more. Here we go. Airplane flying south. Okay, from the north, so flying south at 181. I'll just write that down so I remember. It's 181 kilometers per hour. In fact, we know that that means that the rate of change of the y with respect to time, this is hard to control this, is 181. Okay, I say 181, but I always have to check. Is the distance getting smaller? Of course, this is the airport right here. So yes, the distance from the airport is getting smaller, so that's going to be a negative 181. Okay, and so your d, so here's your x, and then here's your y, and I should have, let's get rid of that 181 right there. Get rid of that right there. So x and y, and let's make it a little bit more. Try to adjust this, hold on. Okay, and then our dx dt, that's great. Okay, I gotta turn my everything off. Never fail, start a video, get a phone call. So dx dt is, it takes longer to write it, negative 191. Okay, negative 191. And then what else? Let's let this be, I know x, y, but let's let it be s. Because s, I always use the distance. Let's see. Find the rate at which the distance between the planes changes. So that's ds dt. So we want ds dt. We know dx dt and dy dt. But this at the precise moment when the x is equal to, I like the other one better. X is equal to, what is that? Westbound plane is 21. So 21. And the y has a value of 34. And that should be enough information. The relate step, hopefully, is obvious. X squared plus y squared equals, maybe putting a z there would have been better. Should make it a z. S squared. Boy, that takes a long time. I gotta get something better than that. Alright, so there we have that. And then take the derivative of both sides. And after the next step, so remember, want, know, relate, and then differentiate. So 2x dx dt, and then 2y dy dt equals 2s ds dt. Okay, and then I'm dividing both sides by 2. Okay, so we get y dy dt. Oh my gosh, this takes forever. Wow. Equals, I'm committed though, s ds dt. And then, that is just beautiful, isn't it? Nice. Put the x, the y, and then this s right here, let's use a fancy color there, that one. Right there. That s right there, you're going to get that by plugging in 21 and 34 into this equation here. And you're trying to find ds dt, so plug in all the numbers and you'll get your ds dt. Okay? There you go. That's a wrap.